Good morning, one and all. Welcome to the second lecture of Module 5 for the course ME404 Industrial Engineering offered to the 8th semester Mechanical Engineering students. I am Mathew Baby, Assistant Professor with the Department of Mechanical Engineering at Rigidity School of Engineering and Technology. Now, in this lecture, we will be dealing with production planning and control, one of the major functions in production. In short, we call it as PPC. So we'll see what production planning is, what production control is, etc. in this lecture. Now, production planning and control, or in short PPC, is one of the major functions in a manufacturing organization or in any organization for that matter that is involved in production of products or goods. Now, we call it as PPC because even though it involves two activities, that is production planning and production control, which are two separate activities, these two separate activities are interrelated and interdependent on each other. So that is why we club these two together and call it as a function called production planning and control. Now, to give you an introduction as to what production planning is and what production control deals with, I would like to discuss the following points. So the first aspect is production planning. Now, production planning is a pre-production activity or an activity that takes place prior to any production. Now, this is a technique of foreseeing every possible step in a long series of operations. For any production activity, you are required to carry out a series of operations, a series of steps. Now, the technique of foreseeing or forecasting what these series of steps will be, where they will be done, when they will be done, etc. So that particular process is referred to as production planning. So in general, production planning is a technique of foreseeing every step in a long series of operation where each of these steps in the series is done at the right time, at the right place, by the right people with maximum efficiency. Now, production planning is an activity that helps us to estimate the quantity of resources required to produce a predetermined level of output in a given period of time or a given time frame. So this helps us plan what are the quantity of resources. The resources might be materials, manpower, machines, finance, etc. So it will help us to estimate the quantity of different resources required to produce a certain quantity of output or a predetermined level of output in a given period of time. For example, production planning will help us to estimate what would be the amount of materials, what would be the number of manpower, what would be the machines that will be required to produce, say, 10,000 units of products X in the next 1 month. So a production planning helps us to estimate the quantity of resources required to produce a given output in a given period of time. Now, coming to the second aspect of this function, that is production control. Now, production control is an activity that helps in monitoring and controlling of all operations involved in production. So in production planning, we plan what is to be carried out, whereas in production control, we monitor the activities, the execution of the activities that are planned. Once you have a production plan, you then implement your plan. And while implementing plan, it is necessary that you control all the operations so that you ensure that all the activities are going according to the plan. So production control is a function that helps in monitoring and controlling all the operations involved in the production process. And here it analyzes the variation in the actual achievements against set targets. In the production plan, you establish targets that needs to be achieved in a given period of time. In production control, what you do is you monitor all the activities, you check whether the activities are going according to the plan, and if there are any variations, you check what the variations are. You analyze the variations and compare those variations against the required targets. And if there are any variations, you take the necessary corrective actions to overcome those variations. So that is what you do in production control. So even though production planning is a pre-production activity and production control is an activity that takes place during production, these two functions or these two activities are together clubbed as one function called production planning and control. Now this is because the control or the production control function is what helps achieve the production plans, and also production controls gives the planning department the necessary feedback as to how a particular plan can be modified. Sometimes certain plans might not be practically feasible. So once you put it into practice, you see that it is never possible for the production team to achieve those particular targets set by the production plan. So you might need to modify your plans, and this suggestion or feedbacks that you require to modify plans that make that plan more realistic, it comes from the control function. So control helps achieve the plans that are put forward and also gives a feedback to modify plans. Similarly, for production control to take place, you have to measure variation of actual achievements against set targets, and the targets used for controlling the production activity are set by the production planning activity. So that is why the production planning and control functions are deeply interrelated and interdependent, and that is why we generally club these two separate activities into a single function called production planning and control. Now, in short, production planning and control, or the function PPC, is a function in any manufacturing organization that involves the planning of production in a manufacturing organization before the actual production starts, and controlling the activities to ensure that the planned production is achieved or is realized. So it's a function that involves planning of production in a manufacturing organization before the actual production and controlling the activities that are established as per the plan to ensure that the planned production is achieved or realized. Now, the planned production is achieved or realized in terms of the quantity of products produced, the quality, the time, delivery schedule, and also the cost of production. So the production plan establishes what should be the quantity, what should be the level of quality to be maintained, what is the time frame under which the production has to be carried out, and also what is the cost or what is the cost limitation under which the production activity has to take place. So the function that involves planning of production in a manufacturing organization before the actual production starts and controlling the activities to ensure that the planned production is achieved in terms of quantity, quality, delivery schedule, and cost of production is referred to as production planning and control. And proper functioning of the production planning and control function ensures that your production is effective and efficient. That means it produces or it achieves the required target, and in achieving the required target, it uses as minimum resources as possible. So proper production planning and production control is necessary or vital to ensure effective production and efficient production. And production planning and control, it involves or it consists of activities like planning, where you decide what needs to be done. It involves activity like routing, where you decide along what path the production progresses or the route taken by the production activity. So it determines where an activity has to be carried out. Then it also consists of activity like scheduling, where you establish when a particular process or a step has to be carried out. Then it determines or consists activity called loading, which determines who is responsible for a particular process or an activity. It consists of activity like dispatching, which actually gives orders for starting production. Okay, and finally it also involves activity like follow-up or expediting, where you check whether the actual plans are being carried out. You measure any variations, and if any variations are detected, then you think about possible remedial measures. So production planning and control consists of activities like planning, routing, scheduling, loading, dispatching, and follow-up or expediting. Now we'll have a look at the various objectives of production planning and control, or why do we have a function called production planning and control. Now, the basic function or the basic objectives of PPC are the following as listed out in this particular slide. We'll start off with the very first one, that is to ensure continuous flow of production. Production planning and control, it helps to eliminate all sorts of blocks and ensure that the production activity is smooth. Now this is done by proper routing and proper scheduling so that there is no clash in schedules. So when a particular process is to be carried out on a particular machine by a particular person, if you carry out your routing and scheduling activities and loading activities properly, there will not be any delay in the production process. So this will lead to elimination of all sorts of blocks and ensure smooth production. So the first objective is to ensure continuous flow of production. That means non-interrupted flow of production, and this is done by proper production planning. Now the second objective is it helps you to plan the requirement of resources. So you will be able to estimate the amount of resources required. So thereby you will be able to ensure that the required resources are available in terms of both quantity, quality, time, okay, as well as dispatching. So planned requirement of resources is achieved by proper production planning and control. Then coordinated work schedules can be achieved by production planning and control. That means your work schedules will match the master production schedule. We'll deal with the topic master production schedule once we go into production planning in detail. Okay, so master matching, we'll be able to coordinate the work amongst different departments and different people if you have proper production planning and control. Then it helps you to maintain optimum level of inventory. Okay, this ensures that the investment is investment in the inventory as minimum as possible without affecting your production process. So keeping inventory at very high levels is a costly affair. It's much more safer for you to keep things at very high quantities so that your production process is never affected due to lack of materials being available. But keeping high levels of inventory is always an expensive process. So there is an optimal level of inventory that needs to be kept where the cost upon inventory is a minimum possible without affecting your production process. So optimum inventory levels can be maintained, and you can ensure availability also by using production planning and control, because inventory control is one major aspect in production planning and control. Now the next objective is increase productivity. Here you will be, by using production planning and control, you will be able to efficiently utilize your resources, thereby keeping your costs to as minimum as possible. So increase productivity by efficient utilization of resources will lead to reduction or economical production, and this is done by elimination of wastage of resources. You plan what resources are required at what stage, and the required resources are made available at the required time, at the required place, in the required quantities. So therefore elimination, you eliminate any kind of wastage of resources because you have already planned what is the amount of resources required. So this makes production activity, or this basically increases the productivity of the organization by making the production as efficient as possible by keeping wastage to the minimum. Production planning and control also helps customer satisfaction by ensuring that the required products of the right quality and quantity are delivered to the customers at the right time. And finally, it also helps you to evaluate the performances of individuals and departments and make necessary corrective actions. So evaluation of performances of individuals as well as departments can be carried out by the production control, and if there are any necessary corrective actions like training, a modification of a production plan, etc., that needs to be taken, such kinds of corrective actions might also be taken. So evaluation of performance is also a very important objective of production planning and control. Now, the importance of production planning and control. Production planning and control is important because it can help deliver better customer service by ensuring delivery of the right quantity and quality of products at the correct price and at the right time. So production planning and control, it plans the production activity and controls the production activity so as to ensure that the right quantity and the right quality of products are produced at the right cost and in the given delivery schedule. So this helps you serve the customer better. So better customer service can be provided by ensuring that the production planning and control activity or function is working properly. So that is one of the importance of PPC. Then PPC also helps the company have a good public image. Now the public image is basically the way in which the public view a company in terms of its product quality, its delivery commitments, its pricing, etc. So a good public image can be ensured by by ensuring that your production planning and control or PPC function is working correctly. Then it also reduces rushed orders. Effective production planning and control will help you to lower the overtime and lower the rush orders. So you will be able to plan your production activities in such a manner so that you do not have to force your labor into overtime to finish orders at the right time, or you do not have to push your production facility to its maximum to meet the deadlines. So reduce rush orders is another importance. It helps us to reduce the rushed orders. It helps improve plant morale because it tries and avoids unscheduled activities and overtime as far as possible. We plan all our activities in prior so that any kind of unscheduled activities or overtime can be reduced. So any kind of overtime or unscheduled activity generally leads to more pressure on the employees in the plant. So if you plan things properly, this kind of overtime and unscheduled activities can be reduced to as minimum as possible, and this will lead to an improved plant morale. It also helps you to maintain optimum inventory. Minimum inventory or minimum investment in the inventory can be ensured while ensuring availability of resources as per requirement without any delay. Then PPC also ensures effective utilization of equipments. It reduces idle time of man and machine, both equipment and machine. The amount of time that they sit idle or without being involved in any productive activity, that can be reduced by proper production planning and control. And also finally, it lowers the capital requirement, because if you have proper production planning and control, it leads to efficient utilization of resources where the wastage is kept to as minimum as possible. So that leads to lower overall capital requirement. Now coming to the major factors that can affect the production planning and control function or the PPC function, there are four major factors that can affect PPC. They are market forecast, types of products, the type of manufacturing, and the volume of production. So the very first factor is a market forecast. That is the trends in the demand as predicted by the forecast. That is demand forecast determines the plan. So the plan generally, any production plan includes the quantity of products to be produced in a particular time period. So whenever the demand predicted by a forecast changes, this will result in a change in the plan, or you are required to make a change in the plan, either an increase or decrease in the production quantity to meet the demand as predicted by the forecast. So the very first factor that influences PPC is a market forecast. Change or trends in demand predicted by the forecast determines the plant, which might require either an increase or decrease in production. The second factor affecting PPC is the type of product. Now, complex products with more complex components requires much more complex planning and control. So where you'll have to maintain more records. So you have to you require more resources. You are required to manage more resources, and hence you are required to manage more or maintain more records. So when the product becomes complex with more components, the planning and control becomes complex because there is a lot more number of steps or number of processes involved in its production. Now, the third factor affecting PPC is the type of manufacturing. Now, for mass manufacturing, where a company produces one or two standardized products, the production planning and control is easy because they deal with very low variety of products. Whereas in a job manufacturing facility or a job manufacturing production system, they deal with a wide variety of products that are produced according to consumer order. So though they are made to order by the consumer, and this makes production planning and control because they do not have a standardized process. So each product or each job order that comes in from a customer requires a specific production plan and control to be established, and it is very difficult to schedule things because there are wide variety of products being produced in the same facility at the same time. So PPC is more difficult in job manufacturing, and whereas in mass manufacturing, in which you produce products which are made to stock, the production planning and control is easy because the variety of products produced is less, or the production is generally more standardized. And the last factor that affects PPC is the volume production. Larger the volume of production, larger will be the amount of records to be maintained, and thus PPC becomes, or the PPC function becomes more difficult. So these are the major factors affecting production planning and control. Now, coming to the limitations of production planning and control. The first limitation is the rigidity, that most of the times the production plan and the control systems that are established as per PPC are rigid, that they are not flexible enough to accommodate for any short-term changes. So any sudden changes in the demand, it's very difficult to modify your production plan and your control systems to accommodate for the change in demand. So any change in the system, any change in the external factors which will affect the plan, it's very difficult to accommodate the change for that particular variable in the production plan. The second limitation is that it is difficult for small firms to have an exclusive function or department dedicated for production planning and control, because the production planning and control requires a lot of manpower, and it also requires a lot of resources. So it's very difficult for small firms to have an independent function called production planning and control, and it's also a very costly affair. So the planning department and the control department requires a lot of labor, so it's generally very costly as well as a time consuming affair. And at the same time, production planning and control is also dependent on external factors. Now, we have seen the major factors affecting production planning and control in the previous slide. So as it is dependent upon a variety of external factors, it is not always truly dependable. So its dependence upon external factors is also one major limiting factor for PPC. Now, the major functions of production planning and control are six. They are divided into six different functions. The first is planning, the second one is routing, the third one is scheduling, the fourth one is loading, the fifth one is dispatching, and the sixth and the final function is follow up or expediting. Now, function one is where you actually plan how the production is going to take place. So you list out the series of steps that a particular raw material might pass through in its transformation from the raw material state to the finished goods state. So that is what you do in planning. In routing, you specifically decide as to what the route or what is a sequence of operations to be carried out, or in what route or what is a flow path for a particular raw material in being converted into a product. So in routing, you decide upon the final route to be taken by for a particular manufacturing operation. Okay, and then the third function is where you schedule, where you specify times as to when a particular activity has to be carried out. The fourth function, loading, is where you actually assign works to different people. So you'll be assigning or you'll be transferring responsibility for a particular work to a particular person. And the fifth function is dispatching, where you actually give production orders and ensure that the necessary resources are made available for production. So dispatching is where you actually basically give production orders and start production. And the last function is follow up or expediting, where you check whether the plan has been established or plan has been executed as per the established plan, or if the actions are executed as per the established plan, and if there are any possible deviations from the plan, then you think about making corrective or taking corrective actions. So these are the 6 different functions, and these functions are divided into 3 phases. Function 1, 2 and 3, the ones that are colored in red, that is a planning, routing and scheduling function. They fall under the planning phase, and this is where actually what is to be done, where it is to be done, and when it is to be done is decided. So actions or functions 1, 2, 3 fall under the planning phase. The function 4 and 5, that is loading and dispatching, is the action phase where you actually uh, carry out the production activity. And the sixth function, that is follow up or expediting, is a control phase. So our control phase of production planning and control. So the functions, the 6 different functions of PPC are divided into 3 basic phases. The planning phase, which constitutes planning, routing and scheduling functions. The action phase, which is constituted by the loading and the dispatching phase. And the expediting function, which constitutes the control phase. Now we'll have a look at the functions of PPC in detail. So the very first function is planning. Now the sequence of operations in planning is such. It starts off with deciding a plan called a business plan. Then you again specify aggregate plans. You make master production schedules or MPS, and you also specify the materials requirement planning. So this is the sequence of operations that are carried out in planning. It starts off with business plan, then you specify the aggregate plan, you make the master production schedule and the materials requirement plan. So the business plan, the very first sequence in the operation of planning, is stating or defining the business plan. Now, business plan is a broad statement of what the firm proposes to do or achieve in the future. Now, this particular statement is generally a long-term statement and is generally expressed in terms of annual, quarterly, or half-yearly or monthly outputs for the broad product range that the firm produces. So generally business plans are not specific to a particular product, and it is generally for the entire business. It's generally expressed in terms of the output or volume of sales or volume of production that is required over a long period of time, which is usually a year, half a year, quarter of a year, etc. So generally business plans are proposed for the entire range of products that the firm produces and is expressed in terms of a quantity that has to be produced over a long period of time. So the basic essential characteristic of a business plan that it is made for the entire business and not for a particular product. For example, an example for a business plan for an automotive manufacturer is to have certain amount of rupees of sales for the car or certain quantity of cars to be produced, not specifying the rupee sales for different models of car or not specifying exactly what will be the quantity of car that is produced for different models. So that kind of a plan is referred to as a business plan. Okay. Now once you have the business plan, The next plan that has to be made is an aggregate plan, and this is generally planning of the quantity and timing of output over an intermediate time period which ranges from 3 to 18 months. So such a kind of plan is called as an aggregate plan. So aggregate plan deals with the quantity of products and timing of output over an intermediate time range or a time period which can be somewhere between 3 months to 18 months. So this is one of the major planning activity which drives the production, and just like a business plan, this is not specific to a particular product. So here the resources are considered to be common for all the products that are made in that particular company. So for the entire business, for all the product, that means for the entire product line that the company produces, the resources are considered to be common, and we are going to make a plan as to what will be the quantity of total products produced in a given amount of time, which is an intermediate time period. So it is not specific to a particular product. In that particular regard, it is generally very similar to a business plan. But business plan is basically a very long-term plan, and generally it is expressed in terms of sales volumes or sales revenues that has to be generated over a particular period of time. So the input towards aggregate plan are the demand forecast that is made, the plant capacity, the levels of inventory available, and the available workforce size. It's based upon these inputs of forecasted demand, the production capacity of the plant, the levels of inventory, as well as the available workforce size or the manpower size. It's based upon these inputs that you plan or you make an aggregate plan. An example for an aggregate plan is a total manpower required in the plant for the next 6 months, and it is irrespective of the products. So if a company makes, say, 3 products A, B and C, the total manpower required to make a particular amount of products during the next 6 months, that is an example for an aggregate plan. It is irrespective of whether the manpower is involved in producing product A, product B or product C. So the total entire manpower required for that entire plant, irrespective of the product that is being manufactured. Such a plan is referred to as an aggregate plan. So aggregate plan is generally specified in terms of quantity and timing of output, and this is a plan that has an intermediate time period, okay, somewhere between 3 to 18 months. The next kind of plan is, once you have aggregate plan, the next kind of plan that is prepared is a master production schedule, which is abbreviated as MPS. Now in master production schedule, you plan the quantity of each finished product to be produced in a period of time. So here your plan becomes specific to a particular product. It is not product independent. You are planning the quantity of finished products to be produced in a given period of time, and this is product specific, and the time period usually is a short time period, or it's a short range where we predict what will be the quantity of a particular product, say product A, being produced in a few weeks or several months. So that kind of a plan which is specific to a particular product and is specified as a quantity of finished products of a particular type produced in a short time period. That kind of a plan is called as a master production schedule. And the last kind of plan is a materials requirement planning, and this specifies the quantity and timing of purchase of various raw materials needed as per the master production schedule. So according to the master production schedule, the quantity as well as the time at which various raw materials are needed. The plan that deals with such kinds of quantities and timings of various raw materials needed as per MPS, considering its cost, is referred to as materials requirement planning. So these are the different kinds of planning that is done as a part of production planning and control. So different kinds of plans are, it starts off with a business plan, then you specify the aggregate plan, a master production schedule, and a materials requirement plan. Now this particular slide shows what the difference between aggregate plan and master production schedule is. Now if we have a look at the aggregate plan, now say the aggregate plan is generally made for intermediate time periods. Okay, so, and you can see that it is irrespective of particular product. So in the month of January, you have an example over here. Take the case of, say, month of April. You have 20 working days in the month of April, and according to the aggregate plan, you have to produce a total number of 20,000 units over the 20 working days in the month of April. So here the quantity to be produced over an intermediate time period of 1 month is specified irrespective of what is the product. So the 20,000 that is specified as a unit to be produced, number of units to be produced over the month of April, is irrespective of the product. It might be a combination of product A, product B, and product C. So if for example, let us take a case where the plant produces three products, product A, B, and C, on the same production line, okay, or in that particular plant. So in the month of April, the sum total of product A, B, and C that has to be produced is equal to 20,000. So such a kind of a plan is referred to as an aggregate plan. Now when it comes to master production schedule, now these are nothing but specifications of the quantity of products to be produced over a much shorter period of time, okay, say probably a week, and this is a quantity that is specified for a particular product. It is not specified as a quantity of the different kinds of products put together. So you can see that in the case of April, which is considered by 4 weeks, the 14th, 15th, 16th, and the 17th week of the year. Now we have three products A, B, and C that have been produced in the same plant. Now in this particular month, you can see that during the 14th week, you have to produce a total of 3,000 units of product A, 1,000 units of product B, and 1,000 units of product C. So in that particular week, that's the first week of April, you have to produce a total quantity of 5,000, but it is composed of 3,000 units of A, 1,000 units of B, and 1,000 units of C. So you are specifying the quantity of products to be produced, okay, specific to a particular product. Okay, so product A this much quantity, product B this much quantity, and this particular quantity that needs to be produced is specified over a very short period of time, like a week. So as compared to a month that is specified in the aggregate plan. So you break down the total monthly production that is required for the entire range of products produced by the plant into weekly as well as product basis breakdown. So that breakdown by week and by product is what you do in master production schedule. So it's an expanded or a detailed form of aggregate plan that you make in the master production schedule. Okay, so in week 15 they have to produce only 2,000 units of A, no units of B is to be produced, and 3,000 units of C has to be produced. In week 16, that is the third week of April, they have to produce 4,000 units of A and 1,000 units of B and no units of C. And during this last week of April, that is the 17th week of the year, you have to produce 5,000 units of A and B and C. So you can see that the total production capacity here on a weekly basis is limited to 5,000. Okay, and the total production capacity, the entire total production capacity is limited to 5,000 per week. So you take the sum total of 14th week, it's 5,000, 15th week, it's 5,000, 16th week, it's 5,000, and 17th week, it's 5,000. So they are distributing the entire production capacity over the entire week, okay, and then you're dividing it among the different products. So during the entire month of April, they are producing a total of 5,000 plus 5,000 plus 5,000 plus 5,000 units of products A, B, and C put together. So in total, they're producing 20,000 units of A over the entire month of April, and the sum total of product A, B, and C put together. That is this particular unit, 20,000. Okay, so I hope this particular graphical representation or diagram represents or basically helps you understand or differentiate aggregate plan and master production schedule. Now the next function to be carried out by PPC is routing, and routing is nothing but the selection of path or route over which each product has to travel in its transformation from the raw material state to finished products or finished goods. So while a raw material has been transformed in its shape, size, in its finish, in its material properties, etc., and it's been converted to a finished product, it has to pass through various processes, and these processes have to be done in a particular order. So there is a specific path or route over which the raw material has to travel during its transformation from the raw material state to finished products or finished goods. So this specific selection of route, the activity that involves the selection of path, is referred to as routing. Now this involves the following activities. It involves determining the quality of products to be manufactured. Now the quality of products to be manufactured determines the resources required, like what is the material required, what are the machines required, where do you carry out the production, what is the sequence of manufacturing operations to be carried out, etc. So determining the quality of the products that needs to be manufactured, that is the very first activity that happens in routing. And the quality required determines the resources, the sequence of operations, and the place where the activities take place. So the first activity involved in routing is determining the quality of products that need to be manufactured. Then after you have determined the quality, then you determine the resources required, like what are the materials required, what are the machines to be utilized, what is the manpower required to carry out that particular job, etc. So once you have assessed the resource requirement, the next determination is you're also involved in determining the types of manufacturing operations required, okay, the number of operations required to produce a product and their corresponding sequence. So manufacturing a product might not just involve just one process or one type of manufacturing operation. It might require a use of a large number of manufacturing operations. So what is the type of manufacturing operation required? Okay, what is the sequence in which these manufacturing operations are required, and how many number of these how many times each of these manufacturing operations have to be carried out? That depends upon the quality of products required. So you have to determine what is the type, what is the sequence, and what is the number of manufacturing operations required to produce the product. And also in routing you determine the place, which specific machine in what routing is used for carrying on that particular operation. So you determine the place of production as well in the routing process. So routing starts off with assessing or understanding the quality of products to be manufactured. Then based upon the quality of products, you determine the materials, machines and manpower, that is the resources required. You also determine the types of manufacturing operations, their sequence, and the number of times these manufacturing operations have to be carried out. Now to explain this, I'll just give you a simple example. Take the case of manufacturing of a turned surface, say a bolt. Okay, so it might require first of all you turning, plane turning a particular cylindrical rod, then carrying out a chamfering operation, and then thread cutting operation. So there are number of manufacturing operations that needs to be carried out in manufacturing a particular bolt. So these operations have to be carried out in a series or in a particular order. You cannot have first threading and then cylindrical turning. There's a particular order in which they have to be carried out, and sometimes in a threading operation you might have to make multiple passes. So the number of times a particular manufacturing operation is repeated, that is also of significance, and that is determined by the quality of your product that needs to be manufactured. For example, if you are using a particular finishing operation, say grinding, to finish your product at the very end. Now sometimes you might have to use multiple passes of grinding to get the required finish. So it is the quality of the product that needs to be manufactured that determines the kind of materials used, the kind of manpower used, the machines that will be used, the manufacturing operations, their sequence, the number of times the manufacturing operation is used, etc. Okay, so these are the activities that are performed as a part of routing. Now, the best route is one that minimizes cost and ensures quality. So there are various techniques that are generally used for routing in production planning and control. One common technique is the use of route cards. Now, a route card is a card that is usually always one that accompanies the job. Okay, it's tagged to the job, and when the job moves along, this route card also moves along. And on this route card, you record the progress of operations on the material. So as the material passes from one operation to another, the progress of operation is basically recorded on this route card. So that is one technique of routing. The second technique is a technique called use of worksheets. Now, worksheets, they contain specifications while manufacturing and instructions regarding the route, that is the machines that needs to be used. So, for example, it might contain the specifications, what are the final specifications required, the size, the shape, the finish, etc. So specifications for manufacturing a particular component are specified on the worksheet. At the same time, it also contains instruction regarding what machine has to be specifically used. For example, in a plant, there might be multiple leads or multiple kinds of leads, and each having a particular machine number. So specifically, the instruction will give you or will ask you to use this particular machine with a specific machine code while doing this particular operation. So the specifications as well as instructions regarding route are clearly specified on a worksheet. Now the next technique is the use of route sheets. So in route sheets, it contains specific manufacturing orders, which are generally department level orders. So it also specifies the route that a particular component or a raw material has to pass through in its transformation to the finished product through a particular department. So that technique is called as route sheet. So it's a very specific kind of worksheet that is specific to a particular department. So route sheets are specific or much more detailed worksheets which contain specific manufacturing orders or instructions that has to be carried out at a particular department. So it's a department level worksheet. You can call route sheets as department level worksheets. And the last kind of technique is basically move orders. They are not specifically used for routing, but rather they are generally a technique that is used for production control. So here, a move order records a quantity of raw materials that are passed forward to the next operation in the sequence, or the ones that are scrapped and the ones that are rectified. And this particular record or the move order is returned to the office after operations are being completed. So this basically helps you to assess the quantity that is moved forward from each station, what is the amount that is scrapped, and what is the amount that is reworked and rectified or corrected, so that it can move forward to the next station. So these are the basic techniques that are generally used for routing. Now this figure shows the route card. That's a technique that is used for routing operation. So this contains the operations that needs to be carried out, and the operations are arranged in the sequence that they have to be carried out in. So this particular route card is attached to the workpiece as it moves from one station to another, and at each station they record the details as to what is the amount that is produced. So when it is produced, what shift, what is the machine that is used, the quantity that is okay, the quantity that is rejected, and the operator name or number. So these are the things that are generally recorded. So this is a card that actually moves along with the work or the workpiece as it moves from one station to another in the order of the processing sequence. So this is what a route card actually looks like. Now, once the route has been decided, the next major function that needs to be carried out is to schedule your job. Now, scheduling job means establishing a time frame under which these activities or these planned activities has to be carried out. So this scheduling determines when a job has to be done, and it consists of starting and completion times for various operations. So it specifies when a particular action starts and when a particular action ends. So as I told you, in a manufacturing operation, in manufacturing a particular product, you might have to use various manufacturing operations, and these manufacturing operations may be done at different times. So there is a time at which a manufacturing operation starts and a time at which a particular process ends. So this is recorded in scheduling. So scheduling basically allots a time for work, a process or work to be carried out. So the most common techniques used for scheduling are Gantt charts, flow process charts, and general network techniques. So you might have learned about the common network techniques like PERT, project evaluation review technique, and CPM, critical path methods. So you have already learned them in your principles of management. Now, the other common technique is by using flow process charts. Now, we have already learned this in the previous modules and in this particular course, ME404 Industrial Engineering. The most common technique that is used is it's a Gantt chart, and Gantt chart is nothing but a graphical representation that shows when a particular activity starts and when the activity ends. It also represents the relationship between different activities. It represents activities which overlap. Okay, so here in this particular slide, you have a figure that shows the production schedule or the Gantt chart for a particular person. A person who's involved in a job, say he's involved in a particular project, and he in that particular project he carries out various works. So the various duties and the works that are carried out are listed out over here, and each of these duties, they start at a particular time and end at a particular time. So those duties, the starting time is specified along with the ending time. So the next duty starts at a particular time, ends at a particular time. And this particular way of graphically representing the various activities, their start times, end times, and the relationship between various activities, whether they overlap, whether we have activities that only start once a previous activity has been complete. So such kinds of relationships among activities can also be identified or represented using a Gantt chart. So the figure that is shown over here is a Gantt chart that shows how a worker carries out his duties, his various functions. Okay, so that is what we do in scheduling. So the third important function of production planning and control is scheduling, where you establish a time frame or time at which an activity has to start and time at which that particular activity has to end. Now the next function of PPC after scheduling is loading. Now before going into the term loading, we will first discuss the term load. Now load is a total amount of work that needs to be assigned, or it's an amount or quantity of work that has to be assigned to a particular entity. That entity can be a person or a work center, okay, a place where work is happening, or it might be assigned to a particular operator. So the amount or quantity of work that needs to be assigned is called as load, and the process of assigning work to a work center or an operator is called as loading. So generally in loading, you assign a sum total, or you assign an aggregate amount of work to specific entities. You are not concerned about what is the work. You assign works, one or more works, to specific entities. So loading is concerned about only assigning work. They are not concerned about what is a schedule, what is a route to be followed, etc. So they generally assign work to work centers or operators. So this determines basically who will do that particular work. Now by the term who, it does not necessarily mean that it's a person. The work can also be assigned to a work center, which can be a machine or a group of machines. So this, whenever you assign a work to a machine, generally there is an operator for that particular machine. So the work is naturally being loaded on the person who is responsible for operating that particular machine. For example, if for the next week a particular machine has been loaded for the entire week for say 24/7, okay, so then the people who will be responsible for that particular work will keep on changing as the operators keep on changing with shift. But the work that is assigned to that particular machine remains the same. That means the machine has been loaded for the entire week, and it is the responsibility of the operators that are working on that particular machine. Now, the operators keep on changing from one shift to another. So the load is basically distributed among different workers. But this particular load has been carried out by, or it's been carried or taken up by a single machine. So loading basically determines who will do the work. Okay, and by the term who, it can be a person or it can be to a particular work center. Now the common inputs that are required for loading are the route plans, the route along which the work progresses. So that will determine what are the work centers required, or who are the operators who are required to be loaded. So the route plan determines who or what are the work centers that are required. Then the schedule determines what are the due dates when a particular work has to be completed by. So the deadlines or the due dates are specified by the schedules. And then the gross or the total man or machine hours available. What is the total time or total available time that a particular man or a work center or a machine is available for productive purpose. So the gross total available man or machine hours is also a major input towards loading. So you should know your route plan, you should know your schedule, and you should generally know what is the total number of man or machine hours that is available in a particular area. So there are basically different steps towards loading. The very first step in loading is choosing the load center, where a particular work has to be carried out or who is responsible for doing a particular work. Now a load center, as I told you, or a load center or a work center can be a machine, a group of machines, or it can be a particular person or an operator. So choose where the load or the work has to be carried out, and this particular choosing a load center is based upon the route plan. For example, in a route plan, you are required to turn a particular component. Now, in the turning department, you might have multiple number of lathes that are available for turning purpose. So, amongst the different lathes available, which is the one that you assign that particular work to? So, that is your load center. So, you have to choose your load center, that is where the work will be carried out, okay, or to whom that work will be assigned. Then once you have chosen the load center, you should develop efficiency factors for load centers. What will be the predicted or what will be the expected efficiency for that particular load center? If you give 100 units of work in a particular time period, what is the expected output or expected correct number of outputs or outputs in the correct quality that come out from a particular load center? So to develop or define these efficiency factors for the load centers. Then the third step after you define the efficiency factor is determine the capacity of the load centers. That is a gross hours available, okay, or the gross available hours is very important. Now determining the capacity of load centers is basically essential in the kind of loading called finite loading, where you do not load a particular machine beyond its capacity, or a load center or a work center beyond its capacity. So determining what is the capacity of a particular load center or a work center is very essential. And by load center, I mean the gross hours available. It might be the gross machine hours or the gross man hours, depending upon the limiting factor, whether it's the man or the machine. For example, take the case of a machine that is available for productive purposes 24/7. That means it can work for 24 hours a day and 7 days a week. But the operator is available say for only for 16 hours a day. So that means the gross available hours for that particular load center is determined not by the the machine's capacity. The machine has a capacity to work 24 hours a day, 7 days a week. But the problem is the number of hours that the manpower or an operator is available to operate that particular equipment is only 16 hours a day. So you have 16 into 7. That is a total number of gross hours that is available on that particular work center. So the limiting factor, it can be either be the machine or the manpower. Generally, in most cases, it's the manpower. So that will determine the capacity of the particular load center. Now, this determination of capacity is essential for a kind of loading called finite loading. So we'll come to that. So the next step after determining capacity is to select the type of loading. Now there are two types of loading that are commonly seen in the loading process. One is called as finite loading, the other one is called as infinite loading. Now in finite loading, we ascertain or estimate the capacity of the load center and we do not load beyond the capacity. So based upon the estimation of the capacity of the load center, you assign a particular work. Say for example, if as in the previous case we saw that we took an example where a machine is available for only 16 hours a day and it is available for 7 days a week. So it's 16 into 7, that is the total available hours. Now when you have work that needs to be done on the machine, which accounts for more than 16 by 7 hours on a weekly basis, then you do not load that particular machine beyond that particular limit. So such a kind of loading process is called as finite loading. In infinite loading, this is a loading without consideration of capacity. We consider the capacity as infinite. Okay, and this might lead to over or under loading. In most cases, infinite loading will result in certain work centers or load centers being overloaded because we do not take into account the capacity of the load centers. So we assume that the capacity of the load center is infinite. So that's the loading system is called as infinite loading. So the fourth step in loading is to determine or to select the type of loading, whether it's finite or infinite. Now these four steps, step numbers 1 to 4, they are managerial decisions. They are taken at the managerial level. So they are activities that are generally part of this is basically the planning part of loading. Okay, and the next step is where you load the scheduled orders into these load centers. Now as per established loads, you have already assigned loads to the different load centers or work centers. You load these work, that means the work is being actually carried out according to the schedules established. So when a particular load is being loaded onto a load center or a work center, that is determined by the schedule that is established in the previous function. Okay, now once the load has been complete or a work has been complete at a particular load center, the last step in loading is unload the completed hours. In certain cases, you might have to unload uncompleted hours or non-completed work as well. So these are the different steps involved in the loading process. Now the next step in production planning and control is dispatching, and the step or the next function is dispatching, and the dispatching basically puts an actual production plan into action. Now this production plan is put into action according to the routing, scheduling and the loading that are established in the previous three functions. Okay, so this sees to it that the materials and required tools are moved to the correct place or correct work center at the correct times. So in dispatching, you give work orders which contain the name of the product or the part, okay, the order number, the quantity that is required to be produced, the operations that have to be carried out for production, their sequence, the tools, the machines required, etc. So what you do in the function called dispatching is basically put your production plans into action. So this is where you actually see the execution along with loading and dispatching. The functions loading and dispatching is where you see actually the production plans being put into action. So dispatching basically sees to it or ensures that the materials and tools are moved to the correct location or correct work center at the correct time. and this is done through work orders. Now work orders, it contains the name of the product or the part that needs to be produced, the order number, the quantity to be produced, the operation for production, their sequence, the tools, machines required, etc. So all these are detailed in the work order, and this work order is what actually basically triggers the production operation. So even if you have a route planned, you have already established a schedule and you have already determined the kind of loading, the production only starts with the release of a work order, and the work order is what actually triggers production. So this is the fifth function of PPC called dispatching. And the last function of production planning and control is expediting or follow-up. Now this is a part of PPC where you actually see production control taking place. So in the functions 1 to 5, that is planning, routing, scheduling, loading and dispatching, you generally see various kinds of activities. Planning, routing and scheduling, you see the planning phase where you actually plan the activities. Loading and dispatching are functions where you see the action phase where the plans are being executed, and the last phase is where you see expediting or follow-up, which is basically a part of production control. Now expediting or follow-up ensures that the plans are being followed during the production process. So the plans that are established as per the production plan, okay, it is ensured that these plans are being followed, and this is done by expediting or follow-up. So this involves reporting production data. Okay, you actually record the production data and you investigate variances from the plan. You investigate if there are any deviations from the actual plan that has been established. Now expediting or follow-up includes activities like checkups to ensure availability of materials, tools, components, etc. Checkup on status of work in progress and completed works. Their times are generally noted, and it also includes activity like reporting deviations to production management so as to take necessary corrective action. So in expediting, we ensure that the plans are being followed. Then you check and record the production data and investigate variances from the existing plan, and if there are any variances, you report it to the production management so as to take the necessary corrective action. So these are the activities that are generally done as a part of expediting or follow-up. So with this, we conclude the topic production planning and control.